Senate Committee on Energy and Environment is called to order. And will the clerk please call the roll?
Chairman McCann.
Present.
Senator Singh.
Present.
Senator Baer.
Here.
Senator Schink. Senator Hertel.
Here.
Senator Camilleri. Senator Chang. Senator Polhinky.
Here.
Senator Lowers.
Here.
Senator DeMoose.
Here.
Senator Outman.
Here.
Senator Houck.
Here.
Senator Bellino. Mr. Chairman, you have 9 members present. There is a quorum.
Thank you very much. I'll entertain a motion to adopt the February 27th, 2025 committee meeting minutes. Motion by Vice Chair Singh. Without objection, the minutes are adopted. I'll make a motion to excuse any absent members, although I think we'll be joined by a couple soon. And seeing no objection, absent members are excused. All right. Today we're going to have a presentation about the state of nuclear energy in Michigan and the United States. And to give a quick opener to that is Ed Rivet from the Michigan Conservative Energy Forum, and then we'll go through the agenda here with the presenters. Welcome.
Thank you, Mr. Chair, members of the committee. As you know, MISEF is an all of the above supporting organization on energy policy. I've testified before this committee on wind, solar, carbon capture, and today it's nuclear. We this morning had an outstanding program of national state experts, many of whom you'll hear from in the next few minutes. We intend to make video available of those on our website, YouTube channel, et cetera. So there were some absolutely fascinating presentations. We also had Kelly Trice, the president of Holtec, gave an update on the Palisades work. Jerry Norcia from DTE also presented very poignant policy issues that he raised. I'm sure you'll hear about those, but I'm just here to let you know that we have a tremendous assembly of experts, and encourage you to ask them questions and learn a lot, because nuclear is a very dynamic field. And with that, I'll get out of the way and let the experts talk.
There we go. Very good. Thank you, Mr. Rivet. And so what I think what we'll do is if everyone's able to stay on hand for the duration, we'll have you do your presentations. And then if members want to jot questions, and we'll keep track, let us know, flag us if you have questions. And then we can bring up whoever wants to answer the questions as they get done. So that being said, I think up first is Indiana Michigan Power, Mike O'Brien, and to introduce some of your good people with the DC Cook nuclear power plant. And whenever you're ready, feel free to begin.
Thank you, Mr. Chairman. As indicated, I'm Mike O'Brien with Indiana Michigan Power Company. I'm Government Affairs Manager for the company, and I brought with me today a couple of individuals who actually know the real work of Indiana Michigan Power, and that is running the DC Cook nuclear power plant. Thanks for the opportunity to be here today. I know you have a busy schedule, so we're going to kind of keep it short. We're not going to go through the PowerPoint. You've got a copy of it there. We'd rather talk a little more conversationally with you about some of the high points, but you've got it there for your reference. And if you're interested in more information, as Ed indicated, we have a continuation of the NEED program this afternoon at 4 o'clock, where Luke and Eric are going to be presenting more detailed information on Cook. And if anybody needs a warm-up after the polar plunge experience, we'll be on the 6th floor of the Louis building. Having said that, I'll turn the microphone over to Luke Ellis, who is our plant manager, supervisor, and then also Eric Lanke, who is the Director of Operations at the plant.
Okay. I'm Eric Lanke. I'm the Operations Director at Cook Nuclear Plant. I'm going to give you a quick overview of what we do and the power we produce. So Cook Nuclear Plant there's 2 units, and we produce approximately 2,300 megawatts. That's about enough power to power 1.5 million typical homes. We distribute power both in Michigan and Indiana. Our original license is when we became operational in 1975 and 1978. Our licenses are set to expire in 2034 and 2037. Given our maintenance of the plant and our excellent operations, we are exploring extending those licenses for a further 20 years. We have not submitted those license amendments yet, but that is something we're pursuing. A high-level overview of how we produce electricity. So Cook is a Westinghouse pressurized water reactor. We have 2 of those, Unit 1 and Unit 2. And we have basically 3 circuits. So the The coolant is heated up within the reactor. That coolant goes through a steam generator, which transfers heat through the U-tubes, transferred to the secondary system, which is pure water. That water boils, produces the motive force to spin 4 turbines. We have a high pressure, 3 low pressure turbines. That steam is ultimately condensed in the main condenser. Again, it's a heat exchanger with tubes. Those tubes are cooled by lake water from Lake Michigan. That water condenses, gets pumped back into steam generators, and we continue the cycle. Moving on to physical protection. So we are a nuclear power plant. So we do have a site security force, and we have a defense in depth strategy. So we have the owner control area, which is about 650 acres. We have a protected area, which is the immediate area around the plant. And then we have the vital areas. Those are areas within the plant that are required for safe and reliable operations.
All right, and I'm Luke Ellis. I'm the plant manager of Cook Nuclear Plant. And I'm going to talk, first I want to talk a little bit about our fuel. So as Eric said, we have two units, and each of those units have 193 fuel assemblies. And to give you a little bit of scale of what a fuel assembly looks like, it's about 10 inches by 10 inches and about 15 feet long. Within that fuel assembly are 225 what we call rodlets, and that's a stainless steel hollow tube, and it's filled with the actual fuel pellet. So the fuel pellet's about an inch, it's about as big as the tip of your pinky finger. And then that's encapsulated in that zircaloy alloy is what it is, and that's the first barrier to keep fission inside the fuel. The fuel cladding is what protects it. A significant benefit I want to make sure everyone's aware of with nuclear energy is the energy density that's contained in that fuel pellet. So that fuel pellet that's about as big as the end of your pinky is equivalent to about 1 ton of coal and a couple hundred gallons of fuel oil. So significant advantage from an energy density standpoint, and what that allows us to do is have a much smaller footprint than most other energy sources. Next, I want to talk about refueling outages. There's typically a lot of questions about spent fuel. So each of our reactors, we refuel every 18 months. We replace 1/3 of the fuel. So that fuel assembly that I initially talked about, that's going to be in the core for 4.5 years. And then it's brought out, and we put it in our spent fuel pool. Now, a lot of people may not realize that all of the fuel that we've spent that we've used since the early 70s is still housed on site. Initially, it was all housed in a swimming pool about half the size of an Olympic swimming pool. With our extended operations, that wasn't going to be quite big enough. So we have done what the rest of the industry has done, and we have a way to store that fuel in a dry cask, and we've done a number of dry cask operations. We have enough room as we sit right now to complete our current licenses, but we will have to expand that storage location when we pursue our second license renewal. So that's the end of our presentation.
Do you think, Senator Blanky, we could hold questions till all the presentations are done, or did you want to?
Question on this presentation. Is this the Cook plant?
Yes.
Yeah, I do have a question.
Well, go ahead. We'll try to keep on track, but yeah.
Okay.
But we can bring them back up too if you.
Sorry?
We can bring them back up also if you'd like. So after the presentations are done. But if you want to ask.
Can I?
Yep.
Thank
course.
you. Thank you, Senator McCann. Thank you. Because the only thing I know about nuclear is when I was 9, 3 Mile Island happened and scared the bejesus out of everyone. So I love that I get to learn more about this. So question for you on this slide about the water in Lake Michigan. So Lake Michigan, you take water from Lake Michigan and it cools it, and then it says it's discharged back into Lake Michigan.
That's correct, Senator.
Clean and perfect again?
That's correct, Senator.
Okay.
That water just comes in, goes through a condenser, essentially a heat exchanger.
Okay.
It goes right back out in the lake. It's very far removed from any of the fission products.
Okay, one second question. The fuel pellets, did you say when they're done, you stored them in a literal pool, a half-size Olympic pool?
That's correct, Senator. That fuel assembly that I described, that 10 inch by 10 inch by 15 feet long,
Yeah.
that assembly that houses the pellets, that remains intact, and it is stored in a pool.
Okay.
Water's excellent shielding for radiation.
Oh, it's stored in a full pool.
That's correct, Senator.
Can that somehow escape and like wreak havoc on our environment?
No, Senator, the way the pool is designed, there's no drain location that is down near the fuel assembly, so it wouldn't be able to drain. And there's a redundant train of cooling that keeps the water cool.
So not possible for that to cause some sort of disaster somewhere?
No plausible method.
No plausible,
I could
thank
think
you.
of, Senator.
Okay.
As I said, we might move on with the presentation and then have any other questions if hopefully you can stay on hand, and I'll come back to you. All right, next up is the Nuclear Energy Institute and the Nuclear Innovation Alliance. Christine and Patrick, if you want to come up and introduce yourselves and begin your talk, you're welcome to.
Good afternoon, Chair McCann and members of the committee. I'm Christine Chismadia, Senior Director for State Government Affairs, and I've spent the last 18 years tracking and advocating on nuclear policies in the United States for the Nuclear Energy Institute. NEI is the national trade association that represents companies associated with the nuclear industry, universities, research laboratories, law firms, labor unions, and electric utilities. Our members are more than 300 and from around the world. Nuclear energy is the single largest carbon-free electric generating source in both the United States and around the world. In the United States, our 94 reactors produced about half of our carbon-free energy. Nuclear plants operating in economically sustainable electricity markets can expect to safely and reliably produce clean electricity for up to 80 years. In fact, the International Intergovernmental Panel on Climate Change recently studied the lifetime carbon emissions by generating source and found that nuclear reactors produce the second lowest amount of carbon over the course of their construction and operation. In Michigan, your 3 reactors provide 23% of your electricity, but over 73% of your carbon-free generation. The nuclear economy supplies a total of 2,650 high-paying, reliable jobs. While the United States once led the world in nuclear energy technology exports, we are no longer the leading supplier of nuclear reactors. We are in a race against the other countries to capture a growing international market share. And by creating a pathway to commercial deployment here at home, we will unlock markets for U.S. technology across the globe. NEI believes our nuclear energy future will include safe, long-term operation of our existing nuclear power reactors through subsequent license renewals and allow operation out to 80 years or more, as well as new nuclear deployment. The existing domestic nuclear fleet is a central part of our nation's critical infrastructure and should not be taken for granted. Policymakers in capitals and in Washington, D.C. have taken action to valuing those reactors for emissions-free generation and incentivizing new nuclear, workforce development, and nuclear supply chain. These actions have had an added benefits of preserving thousands of nuclear jobs and sustaining wages for families. Michigan is in good company. Last year, 25 states took action to support and incentivize nuclear energy. Never before have we seen so much momentum from the states and federal government to support nuclear. The types of policies being considered include states are convening task forces, working groups, commissions to study nuclear energy, which Michigan has completed. Second, states are recognizing nuclear as clean, and clean energy standards or defining nuclear in their state statute, which Michigan has included nuclear in your clean energy standard. Third, states are removing barriers and repealing nuclear moratoriums. In the past few years, 6 states have repealed their moratoriums. And finally, states are incentivizing in different ways, such as in Tennessee, there's $70 million in a nuclear fund to attract nuclear supply chain companies to be located in Tennessee. This session, we're seeing that there are over 250 nuclear bills in state houses across the country seeking to support and incentivize nuclear energy. The electric utility sector in the United States is rapidly evolving, and NEI believes it is in the best interest of the U.S. that nuclear power remains a significant and growing supply of clean energy in this evolution, as this evolution continues. Therefore, it is imperative to the commercial nuclear industry that the U.S. continue to rapidly innovate new products and designs so that these products are available as the market needs them. Thank you for your consideration.
Thank you.
Nonpartisan think tank focused on creating the conditions for success for advanced nuclear energy as a climate solution. It's a little bit of a mouthful, but our organization is funded by private climate philanthropy organizations that are interested in the role that nuclear energy and new nuclear energy can play in helping our country and our world meet our clean energy targets. What really informs NIA's work is modeling that's gone on for decades that tries to outline different pathways to net zero and energy systems that ultimately provide affordable, reliable, and clean energy. And so what we found and what other researchers find is that ultimately a system that balances out renewable energy sources like solar and wind with energy storage can only get you so far without becoming challenging to operate and to run in some areas. However, you can introduce other what we call firm clean energy sources, or energy sources that can provide clean energy on demand. It suddenly makes it a lot easier, and you can get there a lot faster in terms of having an affordable and reliable and clean energy system. And so what we're interested in doing is trying to identify what is the technical analysis and policy analysis that ultimately is useful to help get to that end goal of having a clean energy system. So when we take a look at kind of nuclear energy around the United States, our first question is what role is it going to play? And I think especially in a state like Michigan, as we're trying to identify what are going to be the pathways to meeting the 2040 targets, how can we leverage both the existing nuclear assets in the state and potentially new nuclear generation, not just provide clean electricity, but also think about how we can provide the clean energy that we're going to need for transportation, for industry, and for a variety of other sectors. Ultimately, it becomes a complementary approach in our perspective. We're not picking nuclear or other technologies, it's nuclear and really trying to recognize the role that all clean energy technologies are going to have in meeting our future energy demand needs. One of the things I really want to highlight in the course of my testimony is discussing some of the potential opportunities for nuclear energy moving forward. Historically, when we talk about nuclear technology, we think about it as a base load energy source. It's kind of a stable way to provide electricity for long periods of time. And that's served the United States incredibly well over the past 7 decades in terms of nuclear energy providing that stable, affordable energy that we need. But moving forward, we need to think about how to create energy systems that meet a variety of new demands. How do we think about having energy supplies that ultimately can balance out the changing production from renewables and the changing demand from customers? How can we think about how to decarbonize energy-intensive industries that currently rely on natural gas or rely on coal? And so that's where NIA looks at the variety of different new technologies that are under development around the United States. I want to spend just the last couple of minutes highlighting some of these projects that are currently underway. I think the really exciting thing today is that these are no longer hypothetical projects. These are projects where we've seen significant investment and they're moving forward. So the first one is a partnership, I will say beyond the amazing work that's being done with Holtec over at the Palisades site in terms of kind of thinking about electricity for grid scale production, we're also starting to see alternative uses of nuclear energy. So the first is a partnership between a company X Energy and Dow Chemical to look at how to deploy what we call a high temperature gas reactor or a new advanced reactor technology to provide high temperature heat and electricity to help decarbonize chemical production in Texas. So this project is currently underway, Dow being a significant commercial partner in the project. They're looking at both how to provide clean electricity and also making sure that these chemical facilities can meet net zero or clean energy targets. There's a company called TerraPower that's currently working at developing and deploying a sodium fast reactor technology out in Wyoming. What's really unique about this project is that they're designing a reactor with an integrated thermal energy storage system. So while the nuclear reactor will produce heat equivalent to 345 megawatts of electricity output, it partners directly with a molten salt energy storage system that can ramp its power anywhere from 100 megawatts to 500 megawatts. So we're essentially building in that flexibility and that energy storage that we need so that that power plant can vary its output to match changing grid demands and changing availability from renewables. Again, it's thinking about this in a complementary way. One of the things that we're also seeing is growing interest from data companies and from major tech vendors about how to use nuclear energy as a way to provide the stable electricity they need for any of their technology needs. If you think about AI data centers or other large data centers, rather than powering those with fossil fuels, how can we use nuclear to really match up and provide the co-located energy that they need so they can power these systems without having a negative impact on the grid or on commercial customers. There are a wide variety of other examples I'd be happy to get into in terms of nuclear for off-grid applications or for national security applications. But I think these are the few that really kind of give my organization a lot of excitement about the role that nuclear can play in the United States. And I think as we look towards kind of the energy conversation in Michigan, where there are opportunities for these reactors to both work in the electricity sector, in the industrial applications, and in other industries across the board. So with that, I thank you.
Very good. Thank you so much. And again, if you can stay on hand, we might have some questions after we get through the next presentation. All right, thank you. All right. Next up, from University of Michigan and Monroe Community College, I have Todd and Peter. Welcome, and feel free to begin when you're ready.
Michigan, #1 ranked department in the nation. I'm also the co-lead for the university's hydrogen initiative called My Hydrogen. Before starting a research and academic career, my initial training in nuclear energy was a nuclear-trained submarine officer in the United States Navy. Our department has 24 tenure-track faculty and another 12 research faculty, the largest nuclear energy faculty in the nation. We typically have about 120 undergraduate students and 120 graduate students in the department in any year. Over the last 2 years, the number of undergraduate students has risen sharply. The number of sophomore students taking the Introduction to Nuclear Engineering course that I teach has doubled over the last 2 years. We have faculty with expertise in power reactor design, radiation detection and measurement, material science, plasma, and policy. We try to teach and perform research to address challenges in energy production, national security, environment and health, and fundamental science. Our faculty and students are leaders in the field as examples. Associate Professor Kevin Field was awarded a prestigious Presidential Early Career Award for scientists and engineers for his material science work. Two of our graduate students, Logan Burnett and Natalie Panzik, were awarded prestigious fellowships from the National Science Foundation Graduate Research Fellowship Program. 4 of our faculty members were critical contributors to the recently announced state-supported partnership in high-performance computing with Los Alamos National Laboratory. And Professor Aditi Verma and Associate Professor Kevin Field were named by the American Nuclear Society onto their 40 under 40 list, celebrating their exceptional contributions to advancing nuclear technology. We've established a relationship with DTE. We routinely take students and visitors to tour their plant. We've submitted recently a major proposal with DTE and Monroe County Community College to create a Southeast Michigan workforce and recruiting collaboration for nuclear energy. We host internationally recognized research facilities such as the nation's highest power ultrafast laser and the nation's only triple ion beam material science laboratory. We routinely host national and international events highlighting nuclear energy, including an event called the Global Forum that we will host this fall, and a workshop on advanced systems we co-hosted in Japan with the Hoku University in May of 2024. We welcome the opportunity to help the state grow into an important part of the international nuclear energy supply chain, and I'd be glad to answer any questions that you will have. Thank you.
Good afternoon.
Good afternoon.
Greetings from Monroe County Community College, our staff, our faculty, our students, and also Dr. Quarte, who wanted to be here today but can't be here. Thank you, Senator McCain. Thank you, Senators, for giving us an opportunity to be here. I'd like to talk a little bit about our 2-year associate degree program, a few details about the program, which is one of a kind in the state, and we train technicians that work in the plant. So again, my name is Parmeshwar Peter Kumar. I'm the Dean of the Applied Sciences and Engineering Tech Division at Monroe County Community College. Wanted to say a few words about the program, Nuclear Engineering Technology Associate Degree. We call it the NUET program, NUET. I have a handout here which talks about, which gives you testimonial from students and contact information should you have any other questions on the program. We have been in business since 2009. We started as a unique partnership with Lakeland College in Lakeland, Ohio, that was supplying nuclear engineering techs to First Energy Nuclear Power Plant in Ohio. Initially, the courses were taught at Lakeland and transmitted by video over IP to our campus in Monroe over a big screen TV. A cohort of students attended the lecture. The class was proctored by an instructor who was an employee of DTE Energy, a very, very unique setup for that time. So it was first of a kind. We didn't have expertise. Lakeland was teaching it, and we partnered with them, and it was transmitted video over IP. Remember, this was 2009. Students were awarded a degree from Lakeland College in Nuclear Engineering Tech, and they also got a General Technology degree from Monroe County Community College. It's kind of a win-win situation. They graduated with 2 degrees. Gaining experience in content of course offerings and with encouragement of DTE Energy, we started offering our own program in 2012 with course developed and vetted by DTE Energy, our industry partner, and I'd like to recognize them. They have presented this morning, and I'm thinking there may be Leah in the audience. We have the DTE Energy, as you may be knowing, Fermi 2, one of the premier utility firms in our county, so the partnership was a natural one. The coursework was that we developed was vetted through a gap analysis recommended by the Nuclear Energy Institute and accredited as one that could offer the NUCP certificate, Nuclear Uniform Curriculum Program, otherwise known as ACAD 009. A limited number of students, however, was able to attain this certificate because of the expectation of grade levels and how much you need to get to be able to get that certificate. I'll give you some numbers as I move along. The ability to offer the NUCP certificate gave additional credibility to the program and its graduates. This is accepted by all utility companies around the country, recognizing a certain level of proficiency attainment in the field, otherwise known as industry recognized credential. This is a classic example of a community college giving a degree that had industry recognized credential, and I think my colleague from NIA here can give you more details on NUCP. I can too. We have since graduated 170 students. Approximately 1/3 of them found full-time jobs with our primary industry partner, DTE Energy. Remaining were hired by contractors outside state utility firms such as Davis-Besse in Ohio and utility companies around the country. Some transferred to 4-year higher education with their associate degree. And by the way, I call it primary partner because this is the terminology that we give because the NEI wanted to have a primary partner that would help sponsor. There was a challenge for them through our accreditation process, so they are primary partner, and Davis-Besse has been our secondary partner, but the primary partner is someone that we work closely with. One of the highlights of the program includes core nuclear courses fully taught by DTE employees working in the nuclear industry. We have faculty teaching various other programs, but we planned on having this program taught by people working in industry. So that is one of the highlights of the program. This gives the students a feel for what it is like to be working in the nuclear energy industry. They're continuously interviewing with the people, those who are teaching, because they are also ones that will recommend hiring some of these students. And I gave you some numbers. Out of 170, 1/3 are hired by DTE Energy. Further, there are internship opportunities, just like I mentioned, at DTE Energy, and a required course in the program that takes them through 40 hours of plant experience. So they have internship opportunities and then a required course, which is 40 hours, and they have to go through all of the areas of a nuclear power plant. The program continues to encourage high-achieving students with a higher level of math and science proficiency, which is required by the curriculum. In the curriculum, we have tried to make it prescriptive, but at the same time, we tried to also recruit students that would be competent in a highly technical field. As you may have heard from some of the speakers here, it's a very technical field. Being the only one in the state also brings with it challenges such as not being able to compare with benchmarks within the state. So we benchmark instead with colleges that are around the country. We have about 30 colleges. We initially, I think, started with 70 colleges at the associate degree level. I think a lot of them could not sustain their programs for various reasons, but we have 30 colleges, we being the only one in the state, and we are very looking forward to working with Palisades and A lot of our graduates will go there after they work either at DTE or Davis-Besse. Last but not the least, I want to talk about the compensation for these graduates in this industry. Being a highly technical area, graduates are able to make about six-figure salary within 2 years, 2 to 3 years of working, six-figure salary with an associate degree. So this is very uncommon. This is a classic example of high wage and high demand program. Again, as I have tried to say through my testimony, this is undoubtedly one of the best programs in our technology divisions at Monroe County Community College, and I'm sure it is in the state. It's very lucrative, very attractive, but we have about 50% attrition because people come in the program. The demands of the program are such that, and this is all, like I said, taught by people from DTE Energy, so they're continuously interviewing, and those who survive, they get these kind of jobs. So I'm open for any questions, any comments, other thoughts. Thank you.
Thank you very much, and just kind of take any questions and go backwards in the presentations, if that works all right. I know Senator Lowers, you had a question maybe for one of the earlier presenters. So, but for the folks we have up here now, I think Mr. Allen, you'd said that you'd seen almost a doubling of enrollment and interest. Can you speak to what you might attribute that to?
I think it's a few things. I think that our students are highly driven by climate, right? And they're very pragmatic. And they think if it's a zero carbon energy source, that it should be included. I think you heard testimony about high wages in nuclear. I think that's attractive. I think it's also sort of regained some of its swagger, right, as a cutting edge technology. If you listen to Dr. White's testimony, the new technologies, the new business deployment opportunities for nuclear, I think are just very exciting for them.
Thank you. Any other questions for the folks here? Well, thank you very much. And Senator Lowers, you want to just, was it for the first group or the second group?
I could, Mr.
Please.
Chairman. It was for the first group, but I also wanted to ask Dr. White a question, if that was possible.
So I think we want to have Mr. White and then also the Cook plant folks come up if you can, maybe pull up a chair, but we'll work it out.
Thank you, Mr. Chairman. And I'm kind of directing this to Patrick White, but anyone can answer it. It's a two-part question, I guess. One thing I want to know was, I guess it's a related question. First, I've seen some projections that kind of blow my mind on what potential electrical generation we're going to need going forward, like 200x type projections. And at the same time, I'm looking at the whole picture, wondering what kind of excess production is required just from the standpoint of making storage viable. So I know that's a complex question, but if you can tear that apart any way you want and have at it.
Happy to do it. Thank you so much for the question, Senator. So I think to your first question, we really are looking at potentially unprecedented demand growth for electricity as we talk about both kind of a simultaneous race to net zero and also to meet the growing demands of computation, and as we talk about greater electrification of society, what is that going to mean? Several years ago, NIA had published my organization had published a document called Fission Vision, where we talked about trying to double U.S. nuclear energy capacity by 2050. And we thought that trying to add 100 gigawatts of new nuclear energy was kind of a stretch goal. Well, 2 years later, the Biden administration comes out and says, well, we want to add 200 gigawatts of new nuclear energy in the United States. And that's really only to keep nuclear energy as 20% of our energy generation. So I think this really is a race of we're going to need every clean energy source we can and more. And so that's why we really see prioritization around state support and community support for any type of new generation technology is incredibly needed, which is why we really support the kind of all of the above strategy. To your second question around spent fuel or waste, I think it's an important question because I think it is something that is very pressing for communities. It is a sign of kind of the activities on their land, and it's a longer term conversation about how is the industry, the federal government, and communities going to deal with the question of spent nuclear fuel. And so I think it's important to recognize that in the near term, we do have pathways and we do have methods that can safely manage and store this fuel for decades. We have a demonstrated history of it in the United States, and we've had an incredible success record in terms of safely managing this fuel. I think moving forward, there are going to be more conversations that we're going to need to have about how can we try to develop new processes that ultimately get us to that long-term solution of a deep geologic repository. One of the things that we've seen is this idea of trying to move to what we call consent-based siting methodology. Historically, the idea was pick a site for where you're going to put the spent nuclear fuel and nuclear waste, and then just kind of force the community to take that on. What we found is that really breeds community resentment and doesn't breed trust in new energy technologies. But we've seen demonstrated in Europe and we've seen in other places this idea of working with communities so that they understand what a nuclear waste repository might look like, and then how communities can share in the benefits or be compensated for that, so that ultimately you have a solution that works for society and works for communities. So I think there are pathways on it, and it's something that we do need to solve. We need to continue making progress towards, but I think we have solutions in the near term, so it doesn't need to become a barrier to deployment of new nuclear.
Gonna follow up with the first group then? Thanks, Mr. Chair. So whether it's Luke or Eric, I don't know, but related to the similar topic, but more in general, you know, everyone hears nuclear and they think 3 Mile Island and things like that. I guess just from a safety perspective, you know, what do you have in place that would give comfort to people as they think about the expansion of nuclear's role in our energy generation?
So our current plant designs have built-in levels of redundancy on all of our safety systems. So if you saw the diagram of the plant, we have three barriers to our fission products. We have the fuel cladding that Luke described that contains the pellets. That is one of the fission product barriers. We do have the reactor coolant system itself that maintains it intact. And then we have a containment structure built around that. Those are all 3 fission product barriers. We also have redundant safety systems such that we only need one of them, but we have 2 or more safety systems for both backup pumps, backup power supplies, diesel generators. So we have built-in levels of redundancy at our power plant.
And if I can just build on their comment, I think we've also seen strides over the last couple of decades of even having an increased level of safety at nuclear power plants. Following the Fukushima Daiichi nuclear accidents in Japan in 2011, the nuclear industry undertook a process to figure out how to make the existing plants even more robust. And a really interesting outcome of that at many nuclear power plants is what we call the flex strategy. So essentially all the nuclear power plants, including DC Cook, I've had the opportunity to visit and tour it, now have additional essentially safety equipment that's sited off essentially near the site in a very robust structure that if there were some type of natural disaster, they would have the equipment on site to help respond to that immediately. There are then also what they call the flex regional facilities, which are 2 facilities, one in Tennessee and one in Phoenix, where additional backup equipment is staged and ready, so if there was a need at a facility, they'd be able to get that emergency equipment to the plant to help respond. And so I think you really see this idea of redundancy and defense in depth as being something that is really through and through the nuclear industry. And as we think about advanced nuclear technologies, some of the advantages that we're seeing both in terms of design, reactor fuels, reactor coolants, kind of the underlying parts of the technology, will make it even safer. And so that's, I think, what we hope really is that kind of promise for communities that if they are willing to host and site these new reactors in their communities, we can achieve the high level of safety that's already been demonstrated by plants like DC Cook and even achieve a higher level of safety in the future.
Thank you, Mr. Chair. Thanks for coming today. I have a question about, because it's now in the general news about the small reactors. And in your presentation, I have to admit, I just started laughing when I saw the picture of the micro reactor that's actually a truck ready to drive away really fast. Sorry, it's just a vision, right? Yep. What is the impact of the small and micro reactors when you look at the future? Are we going to have one on top of every data center, right? Will they have their own reactors? Will we have a way to change the model? Or a truck in everybody's backyard, you know.
Thank you for that question, Senator Barry. I will say I'm maybe not enough of a fan of nuclear to say that everyone should have a nuclear-powered truck in their garage, But I think there are a lot of really interesting opportunities to talk about what role nuclear can play in places like data centers. And I think this is something we'll see kind of evolve over the course of the next couple of years and the next couple of decades as utilities and commercial customers try to identify really what are going to be the right energy solutions for their needs, recognizing that that might vary based on where they are in the country or kind of what their ultimate business structure is like. So I think in some places you may see in the future co-sited nuclear power plants where you have a nuclear power plant right alongside a potential end user. A really good example of this is there's the Susquehanna nuclear power plant in eastern Pennsylvania, where the owner, Talon Energy, actually built a data center right at the nuclear power plant. And Amazon has said, hey, we really like the idea that that provides us access to high reliability, clean power. And so we essentially want to buy that data center and be able to run our operations through that. And so I think that's an opportunity to kind of think about that co-location and co-siting. In other places, maybe that doesn't make as much sense, and you can try to think about separating your generation and your use. So, for example, Microsoft has taken a look at what their data center loads are going to be over the next several decades and have said nuclear can play a really good role in help meeting those. So that's why they've worked with the company Constellation to look at the restart, really following in the Palisades footsteps of the TMI Unit 1. Recognizing that it was a plant that was operated well for decades. It was ultimately shut down in the 2010s due to economic reasons. But now there's a need to bring that kind of clean, firm capacity back online. And so that might be one where you get a bit of a physical separation. The last example I'll give you, because you mentioned microreactors and the idea of a reactor on a truck, is this idea of transportable microreactors. I would say that's a little bit farther off, where we're still kind of identifying what are the specific legal and regulatory requirements to get through it. But it really is this idea of how do you get power where it's needed and making sure that it's clean power. One of the challenges you have in many communities and for many applications is that if you need a large amount of electricity, you're either building transmission out to get there, or you're having to truck in things like diesel fuel to power generators. But what if you had an opportunity to get that electricity you needed off grid without needing to have those fuel supply chains and using a dirty fuel like diesel? And so that's where I think there's interest from companies and from the U.S. Department of Defense around microreactors. And so there's currently work by a company called BWXT that builds the naval reactors. They're looking at something called Project Pele to actually demonstrate what the small microreactor could look like for off-grid defense applications. And they're looking at deploying that at the Idaho National Lab in the next several years. They also have civilian models, and there are a number of other companies that are trying to figure out how do you get this reactor where you can get power where it's needed, and then once the power is no longer needed, how can you remove it back and essentially remove that burden off the community? And so that's something that I think we'll see evolve over the next couple of years as customers start to really think about what their energy needs are and what's the right product to ultimately help solve that, really in the bigger context of an all-of-the-above energy strategy. Sometimes it's solar, sometimes it's wind, sometimes it's batteries, sometimes it might also be nuclear.
We're not quite ready for DeLoreans with banana peels, but we're close. We got trucks with,
If we
thank you.
Mr. Fusion, I'll be the first one to buy one, I'll say that.
Call me.
Will do.
Thank you, Senator. Senator Schenck.
Thank
And
you.
again, please, if others feel like they'd like to respond, feel free to musical chair and so forth.
Thank you for being here. I do have to say that Senator Lowers took one of my questions, and I appreciate you addressing it. I'm old enough that when you say nuclear energy is a clean energy, I say, but wait a second. I've actually been subject to contamination from nuclear reactor meltdowns in my life. And so I don't think that is honest when you say that nuclear energy is clean. So that's one issue that I'm facing. The other thing, when I took a hazardous waste siting class in grad school, one of the things that I learned and took from that class was the admonition to always look for a community that is kind of has a low education level and needs the money, and then help them understand how much money you're going to bring to the community. And we have some of those here, and those hazardous siting efforts oftentimes don't bring the benefits they've promised. And so I would just also caution you as you go forth, because I'm sure I didn't tell you anything you didn't already know in that comment, that nuclear waste has a cost to the community. It has a cost to us. It has a cost to us even sitting in these wonderful pools that you've discussed. So my question is that we have a couple issues here. We have a federal government that is freezing funding on a lot of things. There's been talk of not monitoring even, although I understand that that's something that CISA says they're going to continue to do, cyber threats from Russia. There are cyber threats from different angles. And so if we have a government that maybe isn't taking threats like that seriously, or physical threats, because I also see us as we're entering a very destabilized geopolitical situation, which I think is an understatement. How do you prevent your nuclear plants from becoming little bombs or little bombs on trucks? And I don't think, like, I'd love to laugh and say, gosh, that seems hysterical, but unfortunately, I don't think it is. And the best way to prevent disasters is to actually take the steps to prevent them. Thanks.
In multiple ways. We obviously can't get into the specifics of how we're testing, but I can assure you the testing these officers go through is extremely intensive, and we test for all sorts of scenarios, some that seem beyond belief that we would dream these up, but we do very realistic tests to assure that they're able to keep the plant safe.
Very good. No? Yep, please, go ahead.
Thank you, Senator. And I appreciate the clarification around the clean, because I think for folks that do have kind of a longer history with nuclear technology, they may be very sensitive to that. I'll just, for my clarification, when I talk about clean energy, it really kind of is in the larger question around carbon emissions and trying to think about how it affects kind of the global climate crisis. But I do appreciate that we need to make sure we maintain high standards at nuclear plants for things like offsite emissions, for routine and accident conditions, because these can have very real impacts on communities. It can have real impacts on people, and it can have real impacts on the land. And so we do need to make sure that both we have a culture of excellence and a culture of safety amongst operators, which I think we do, and also the role of a strong independent regulator to make sure that those are maintained. And I think that's one of the things that we're really seeing moving forward is making sure that we do have this strong independent regulator that can hold accountability and make sure that the operation of nuclear power plants meet the societal expectation. And so I think that's kind of an interesting path to make sure that we're going down as we're thinking about deployment of new nuclear, maintaining those high standards through industry organizations and through regulation. To your comment about waste, I think it was also a very good observation. At what point does the need for economic development become coercive? And I think that's part of the conversation around these consent-based siting processes, is trying to recognize when can consent from a community actually be obtained. And how do you make sure you have something where you're not just taking advantage of a community that has certain economic needs? And then that's something right now that the Department of Energy is looking through and trying to identify what are the processes that lead to a just and equitable outcome rather than just finding a place for the waste. I don't think we have a solved solution for that yet, but I think it's something that's worth doing because ultimately that's the only way that we're going to get to an end state that ultimately is in the best interest of society and doesn't take advantage of groups that don't necessarily have the ability to push back on siting. On the physical security question, again, I think that's another really good one. I would point to a lot of the work that's been done at a lot of the utilities in terms of trying to make sure their facilities are robust. But I think there is a reason, I think it is very reasonable to have concerns around it when you see things like the Russian attacks on Ukrainian nuclear power plants and trying to understand what that looks like. I think from our perspective, it really is talking about how the existing nuclear power plants in the United States have these layers of defense in depth to try to ensure safe operations and prevent security risks. And then as we think about nuclear power plants moving forward, how are we utilizing new technologies that may be less vulnerable to even any other types of cyber or physical threats? How do you make sure you have a plant that doesn't necessarily rely on having emergency backup power? So if an adversary were to damage backup power systems, that doesn't lead to an accident that could release radiological material. And so it's kind of thinking at a bigger picture of how are ways that we can make our nuclear technology even safer moving forward, both in terms of the physical and cyber threats. But I think those are important things to consider as we think about nuclear taking an even bigger role potentially in energy generation moving forward.
Thank you. Senator Hawk?
Yes, thank you, Mr. Chairman. Yeah, I think you brought up some good points. I see it in my district. I have the biggest wind farm, and now we have solar panels. And if you look at those, I wouldn't consider that clean energy because it kind of pollutes the not the environment, but where you're at. And it's kind of came up into communities where we're doing the power for things down south, but we get stuck with it. So I think we got to look at everything. And I guess the other thing we could do is instead of trying to get communities to buy in, we could just take away local zoning where the state could just force it. and then we could have clean energy everywhere. So I don't know if that's something, I mean, for nuclear, not for, yeah. So, I want everything, but I don't think we can say this is bad and have other bad and not consider it all kind of in the same thing. Thank you.
I'm not sure there was a question, but that's okay. We'll take one last question.
What do you think of that?
I'm happy to provide a.
Yeah.
I'm happy to provide a quick response to that, though, if it's helpful.
Sure.
I'll take it. Just one thing I think we're really looking at with kind of the next generation of new nuclear technology is really this idea of community support for programs is absolutely critical, long-term community support. I think if you look around existing nuclear power plants today, they oftentimes have incredibly strong relationships with the communities. They recognize the way the plants operate. They recognize the jobs it provides. They recognize that it's clean. They understand the technology. And I think we've seen amazing success stories in a lot of communities. I think in other places, however, when you had kind of this historic model of announce, defend in terms of citing new infrastructure, that's where you potentially can build these poor community relations, and you don't necessarily have the communities benefiting from new technology. And so I think this is a process where we might want to say, okay, what's the expeditious way to try to cite new nuclear versus what is a way to create long-term sustainable projects where we can really see that the community, one, wants the nuclear power plant in their community, two, recognizes the value of it, and three, wants to work with them in the long term. I was reminded of someone who was actually in the wind industry, where they use the metaphor 100 cups of coffee per megawatt. And what they said is that for every interaction or for every megawatt of a wind farm that you want to cite, if you really want to get community approval, you need to have 100 cups of coffee or 100 high quality interactions with folks in the community. And I think that's really critical because that's how you understand what are the conditions that are necessary to really get acceptance for that project. And it's about spending the time and doing the work. We've actually seen that take place out in Kemmerer, Wyoming with TerraPower trying to site their Natrium plant. It wasn't just pick a site at a retiring coal plant, put down a nuclear plant, but it was a months or year-long effort of really building community acceptance for that. And now the community is incredibly excited for having this nuclear plant be in their community. And I think that's the success path we want to see going forward, because that's how we create a condition where people want nuclear in their community and aren't pushing back on it because it was something that was essentially put in their backyard without their consent.
All right, and the last question, because we're looking to end at 2:30, is Senator Outman.
Thank you, Mr. Chair, and thank you guys for your presentation. As we talk about, and it's hard going back in my memory bank because we had some of these discussions when I was on Energy and Tech in the House, a few years ago. But when we talk about spent rods and storage of things such as that, if I remember right, there was supposedly a place in the United States that was already made for that, and we just haven't been able to get authorization to use that. But then the other thing that we talked about was how with improved technology, we've been able to spend down those rods even further than we used to be able to, and even some of those spent rods could be used for other things that were, could you elaborate on that a little bit, please?
Sounds good. I always want to let the colleagues from Cook take the first swing at it if they like. Yeah, so it's a great two-part question there, Senator, both on the idea of what were previously identified repositories for spent nuclear fuel and then what are potential options moving forward. So I believe what you're talking about is the Yucca Mountain project that was originally selected by the Congress and the Department of Energy as kind of being the long-term disposal option for spent nuclear fuel. So that's a project out in Nevada, north of Las Vegas, that was selected through a politically contentious process for being the long-term disposal solution for spent nuclear fuel. Ultimately, that's run into several political roadblocks, including opposition from different political groups within Nevada at both this and also folks at the state and federal level. And over the last several years, not a lot of progress has been made on the use of Yucca Mountain. Different folks may agree on whether or not they think Yucca Mountain is a viable strategy moving forward or not. I'll leave folks to have their own discussions on their opinions about the future viability of Yucca Mountain. But I think it does kind of raise a question of if there's been this much trouble around citing that repository, is it a politically sustainable option moving forward? And so in either case, we're going to need to think about what are going to be other ways for us to ultimately come with a long-term disposal option for spent nuclear fuel. On the second half of your question, thinking about other ways that we might be able to do something with the fuel in the future. I think what you're getting to there is this discussion around either spent fuel recycling or reuse of spent nuclear fuel. So the existing reactors we have in the United States, what we call light water reactors, are nominally designed with what we call a once-through fuel cycle. You take your nuclear fuel, you use it in the reactor for 4.5 years like they do at DC Cook, and then you move it into storage. But when you do that, you're only actually using a small amount of the uranium that's in the fuel before you build up things called fission products that ultimately cause the nuclear reactions to stop, and you can no longer use that fuel, and you have to get a new batch of fuel in. There are processes, however, where you could potentially take that fuel, separate out those fission products, and then make better use of that uranium that still remains in the fuel. And that's something traditionally called reprocessing. The idea is, could you then use that as the basis for new fuel that goes into light water reactors, like the ones we have today, by adding in some kind of fresh uranium? Or could you ultimately use that in other types of nuclear reactors, like the sodium fast reactor? It uses it's a little bit hard to explain, but it essentially uses what we call fast neutrons instead of thermal neutrons. And by using a higher energy neutron, it lets you cause fissions from atoms that otherwise wouldn't be splittable in most nuclear reactors. So the first idea of essentially reusing the fuel in existing reactors is actually what France already does with what they call MOX, or a mixed oxide fuel, where they take the fuel from existing reactors and then use it to create the next generation of fuel. This is also something that the Japanese are looking at as well. They have a facility in northern Japan called Rakasha, where they actually do this process. We don't yet have that in the United States, but it would be something that we could look at moving forward. The challenge there is it doesn't necessarily become economically feasible, and sometimes it's easier and lower cost to just use fuel in kind of a once-through cycle. In terms of the fast reactors, that's something that's under investigation, and there are a number of companies today that are looking at how they could potentially reuse fuel to try to reduce that volume or make better use of the fuel that we have today. Companies including Oklo, TerraPower, and there are a number of other sodium reactor companies that are looking at that. So it's something that's, I would say, in the works that companies are looking at to figure out if it's going to be technically and economically viable.
Well, thank you all very much for your presentations today, and members for your questions, and a really good discussion. Appreciate everything. And that being said, do you have a closing remark, Mr. Ribbit? If you would, we'll have you, if you're going to make closing remarks, please come up to the dais. And we don't have you on the system, so we really need you to speak into the microphone, please.
I don't know if you wanted a presentation on, we do have one presentation time yet today, 4 o'clock across the street at the Louis, with a beer and wine social after. So if you need a little relaxation at the end of your session week before you head back to your districts, we will have AEP, Indiana Michigan Power, is going to present in a little more detail with their PowerPoint, as well as Peter Kumar, and a social afterwards. So if you'd like a beer or wine, come on over to the Louis.
Thank you, so noted. No further business before the committee, and without objection, we stand adjourned.